Let's do some examples. So I've written out a couple of examples for us to work through. Number one, a solenoid consumes 750 watts and 825 volt amperes. What is the power factor? What is the phase angle? Where do I start? You start with a sketch of a triangle. And it's only a sketch. Put your numbers from the question into the triangle. 750 watts, the watts is on the bottom. 825 volt amperes, that's the result. 825. So we can now begin to answer the question, what is the power factor? A. So power factor equals, and it's going to be that over that. Okay, in this case it's watts over volt amperes. Put the numbers in, 750 over 825, that comes to 0.91. Okay, there's phi. Let's find part B. Phi, not left myself a lot of room, is cos to minus 1 of this number. So this comes up here, 0.91. That's a squeeze. And if you put that in your calculator, I'm hoping you'll get 39.6 degrees. Okay, so that started with a sketch and using your information. I'm going to carry on and do example 2. A large coil uses 6 kilowatts and 5 kVAR. Find power factor and the phase angle. I've been lazy here, but they'll normally be written out properly in a question. So, sketch the triangle. What information have you got? That's your first thing. Be careful. A large coil uses 6 kilowatts. That goes there, 6 kilowatts. And 5 kVAR. That's up here, 5 kVAR. We haven't got kVA. So the question asks, find the power factor. Well, that means your first step is to find kVA. And it's Pythagoras, the square root of 6 squared plus 5 squared. And that should come to 7.8. So that's kVA. We can now do the power factor. So power factor cos phi equals kW over kVA. Put the numbers in. kW is 6, kVA is 7.8, and the answer to that is 0.77. Final bit, find the phase angle. So phi equals cos to the minus 1, this number. And that comes to 39.6 degrees. Okay, if I'm going too quickly for you at the moment, you're watching this on the video, you can pause, rewind, do whatever you need, just keep going back over it. So let's look at example 3. So in example 3, an AC load has a reactance of 120 ohms and impedance of 200 ohms. Determine the resistance, the power factor, and the phase angle. Sketch what you know. So a quick sketch of the triangle. AC load has reactance of 120. Reactance is up the side. Impedance is 200. That's this bit. Determine R. That's that bit. So this is an impedance triangle. You've got the information for it. We now need to begin to work through it. To calculate R then, Pythagoras, the square root of the big one minus the smaller one. If we put that in the calculator, you should come to 160 ohms. Let's do the next bit, power factor. Notice I keep changing. Sometimes I write PF for power factors, sometimes I write cos phi. I don't care which you use, and you could see either in an exam. So power factor, an important one. This is the impedance triangle. Your formula is R over Z. Put the numbers in. R is 160, Z is 200. That comes to 0.8. Next step, let's find phi. I'm going through routines over and over. Hopefully you'll begin to remember them. Cos to minus 1 of this number, your power factor. And that will bring us to 36.9 degrees. Okay, so there's a couple of examples. Hopefully they'll help you through the questions on the worksheet. I just want to revisit the triangles. I did say I'd do this at the beginning, so let's have a look at it. I have a circuit here, resistor and inductor. I've said let's assume the supply voltage is 500 volts. If I say the resistance is 40 ohms, the reactance of the inductor is 30 ohms, then we can create a triangle. 30, 40, this will be 50. So in case you've missed it, this is an impedance triangle, R, XL, Z. From the information that we have, I could find the circuit current. We know the voltage is 500. I equals V over Z. Put your numbers in. The voltage is 500. Z is 50. That gives us a current of 10 amps. So if we know the current is 10 amps, then we can begin to fill out this. We could quite simply find the voltage across the resistor. And so that's going to be V equals I times R. And that will give us 400 volts. We could find the voltage across the inductor. That is V equals I times XL. So that's going to be 300 volts. And I already told you the supply is 500. And again, we have that same 3, 4, 5 triangle. So to finish with, let's talk about the power that goes in this circuit. If we use that magic formula, P equals VI cos phi, I can find the true power in this circuit, and if you work it out, you'll get 4 kilowatts. You can work out kVAR, and this will be 3 kVAR. And the volt amperes is going to be 5 kVA. So the point of doing this is simple. This is one circuit, and from that one circuit we could produce several different triangles. The most important ones being the impedance triangle and the power triangle. They're all the same shape, but they can have widely different values on them, but they'll still give you the same answer in every one. If I did 40 over 50, 400 over 500, or in this case 4,000 over 5,000, I would get the same power factor in every one.